Okay, trigonometry basics. So let's get into this. Pythagorean theorem. You should know Pythagorean theorem, but it's part of trig basics. So let's get into it. A squared plus b squared equals c squared. Pythagoras. So a and b are your sides. C is always your hypotenuse. So a and b doesn't matter. C has to be your hypotenuse. So that's going to be a squared plus b squared equals c squared, which is 4 squared plus 8 squared equals c squared. So that's 16 plus 64 equals c squared. Well, that's 80 equals c squared. Square root it. So c equals the square root of 80. Break that down. So we have those 2's. So that's going to be 2 times 2. The 5's left inside, so it's 4 square roots of 5. Okay. This one is going to be x squared plus 22 squared equals 24 squared. Well, that's 484 and 576. Subtract that over, you get x squared equals 91. So x equals the square root of 92, not 91. Break down that 92, 2 and 46, 2 and 23. So that's going to be the same thing as 2 square roots of 23. Okay, always break down square roots if you can break them down. Now this part, this is very important to remember, okay? And I'm going to show you like how we come up with this because I think it will help to know where it comes from. So we're going to start with this square. And with this square, that means that all sides are equal, right? So like those 2 sides are equal. I could have even gone like, oh, those 2 sides are equal also. So all 4 of these sides here are equal because it's a square. Okay, if all 4 sides are equal, that also means that all 4 angles are equal. These are all right angles. Okay, well, these angles right here are half of a right angle. So I'm going to go back. So that's half of a right angle. So this angle is 45, which means this angle right here is also 45. Because the whole thing, wait, I should draw as a square. That whole thing is 90. Half of 90 is 45. Okay? Which now I'm just going to call my sides x. So that's x and that's x. Because they're the same side, let's just use x. Now, let's just find the length of that hypotenuse right there using Pythagorean theorem. So it's going to be x squared plus x squared equals c squared. So that's 2x squared equals c squared. Square root that. Well, c equals the square root of 2x squared. We can pull out an x there, so c equals x square roots of 2. Okay, because if you have an x squared, the square root of x squared is just x. So that means that that diagonal here, sorry, I didn't do a very good job about labeling this is x squared, so 2, and that should be 45. Okay, and that is the 45, 45, 90 triangle. So if you ever forget it, go back to the square and figure it out from there. Okay, so that means that our legs here are x, and the hypotenuse is x square roots of 2. This is so important, okay? You need to ingrain this into your mind. Okay, it will help you so much if you can remember this. Cool? We have this other triangle that is very important, and it's the 30, 60, 90 triangle. So we're going to start with an equilateral triangle, which equilateral means we have 3 sides that are the same, which means we have 3 angles that are also the same. Okay, so that means that all 3 of these sides are the same, and all 3 of these angles are the same. Okay, and I'm going to start by just calling my sides. We could start with calling them x, and you'll still end up getting the same thing, but we're going to have like weird fractions in there. So let's just call it 2x. Okay, we're going to call all of our sides 2x. And then since this is an equilateral triangle, that means all of those angles there are 60. Okay, but we're cutting this angle up top in half. So to cut that in half would be 30. Okay, so we're working with the left side of this equilateral triangle. And then same thing down here, we're cutting that whole length in half. Well, half of 2x is just x. Okay, see why I use the 2x now? Now, again, this is a right triangle because this right here is 90 degrees. So again, we can use Pythagorean theorem to find the height of this. So that's going to be x squared plus b squared equals 2x squared. So that's x squared plus b squared equals 4x squared, because 2x squared is 4x squared. Subtract that over, you get b squared equals 3x squared. Square root both sides. You get b equals the square root of 3x squared, which is the same as x square roots of 3. Okay, so this height right here is x square roots of 3. Okay, it's cool to know where that comes from, because I could just throw that triangle at you and be like, yo, memorize this. But I like to know where things come from, especially like I'm doing this master's program right now, and when they just throw stuff at me, I'm like, okay, I'm lost. Like, I don't know what the heck you're doing. So, yeah. Down here, so the shorter leg, that's the leg opposite of the 30, is x. And that's another thing I would maybe write, so opposite of 30. This one is opposite of 60. Okay, and that one is x squared to 3, and then the hypotenuse is 2x. Okay, remember this. And let's get into finding these missing side lengths. So if we have this right triangle, 45, 45, 90 triangle, first what I want to do is look at my 45, 45, 90, and let's label the sides the same way they're labeled on this. So x, x, and x squared, so 2. So x, and I'm just going to write it over here because we have like this x and y thing going on, and we have another x, and those x's mean different things, and so it's getting confusing. So I'm going to put x equals x, and x squared to 2 equals y. Then I'm going to circle the one that they gave me. So they gave me the 10, so I have x equals 10. Well, then that makes it easy for me, because then that means that that x equals 10, and that x equals 10 squared roots of 2. Pretty simple, didn't have to do anything extra. Okay, it will get a little harder. So like this one, x squared roots of 2. So that means x equals x, and x also equals y. See why I'm doing this like x equals y thing? There's just a lot of x's going on, so it's confusing. Now I'm going to look at the one I know. So x squared roots of 2 equals 14 squared roots of 2, and solve that for x. So that means x equals 14. I don't know what that little question mark is. So then both of those are 14. This one, so we have x squared roots of 2, so x equals y. And we have 16 squared roots of 2, or x squared roots of 2 equals 16. Solve that for x, so divide by the square root of 2. And you get x equals 16 over the square root of 2. Rationalize this, so multiply by square root of 2 over square root of 2. You get 16 square root of 2 over 2, which is 8 square roots of 2. So x equals 8 square roots of 2, and both of those are 8 square roots of 2. Okay, let's get into some 30, 60, 90 ones. So for this one, let's label this one accordingly. Also, opposite of 30 is x, opposite of 60 is x squared roots of 3, and hypotenuse is 2x. So that means x equals x squared roots of 3 equals y, and 8 equals 2x, which means x equals 4. So that first one is easy, is 4. The next one's easy too, it's just 4 square roots of 3. Cool? Same thing here, so opposite of 60 is x squared roots of 3, opposite of 30 is x, and then hypotenuse is 2x. So that means that 2x equals x, and x equals y. And then x squared roots of 3 equals 27. Divide by that square root of 3, and you get x equals 27 divided by the square root of 3. Rationalize that, you get 27 square roots of 3 over 3, which is 9 square roots of 3. So for that first one, x equals y, so that's just 9 square roots of 3. We have to double it, so 2 times 9 square roots of 3 is 18 square roots of 3. Okay, one more. So x squared roots of 3, and 2x. So that means 2x equals x, and x squared roots of 3 equals y. So, and we have x equals 5 squared roots of 6. Well, the 2 times 5 squared roots of 6 is easy. That's just 10 squared roots of 6. And then 5 square root of 6 times the square root of 3. Multiply the square root, so you get 5 square roots of 18. If you break that down, you'll end up getting 15 square roots of 2. Okay? Okay, let's keep going. So a trigonometric function is a function whose rule is defined by a trig ratio. Okay, a trig ratio compares the lengths of two sides of a triangle, and the Greek letter theta is used to represent the angle. Okay, and you should know this. That's the hypotenuse. We're looking at this angle right here. So I'm over on this triangle. From that angle, the one I can draw a line to is the opposite side, and the other's the adjacent. Hopefully this is kind of review. And hopefully SOHCAHTOA is review also. So that sine is opposite over hypotenuse. Cosine's adjacent over hypotenuse, and tangent's opposite over adjacent. I like to write it like that, because then it really shows like, oh, these are fractions, so that's SOHCAHTOA. Same thing. But from here, sine, opposite over hypotenuse. Cosine, which in this case was A over C. Adjacent over hypotenuse, which is B over C. Tangent, opposite over adjacent, which is A over B. Now the reciprocal functions are the opposites of sine, cosine, and tangent. Okay? So cosecant is the opposite of sine. And I always remember this because it's kind of confusing. Like you would think cosine should go with cosecant and sine should go with secant. Well, the reason they don't is because sine and cosines are very similar to each other. So like cosine is the co-function of sine. And same thing here, like secant and cosecant. Well, cosecant is the co-function of secant. Okay? And one way to remember this is just like S and C. So sine has to go with cosecant, and cosine has to go with secant. They both have to have an S and a C in there. Okay, and then tangent, cotangent, that one makes sense. So cosecant is 1 over sine, which is really just sine flipped. So that's the same thing as hypotenuse over opposite, which would be C over A. Secant's the opposite of cosine, which would be hypotenuse over adjacent, which is C over B. Cotangent, opposite of tangent, adjacent over opposite, which is B over A. Okay, let's do this one. So we have to find all 6 trig ratios given the triangle below. Well, first we need to solve this triangle for the hypotenuse. So we have 16 squared plus 30 squared equals C squared, which is 1,056 equals C squared, so C equals 34. Now from here, just remember sine, SOHCAHTOA, sine is opposite over hypotenuse, cosine adjacent hypotenuse, tangent opposite and adjacent. So sine would be 16, because opposite. So if we label these, this is the one I can draw a line to, so it's the opposite. Here's the hypotenuse, and this is the adjacent side. So 16 over 34, which is the same as 8/17. Cosine is 30 over 34, which is 15/17. Tangent is 16 over 30, which is 8/15. Cosecant just flips sine, so that would be 17 over 8. Secant would be 17 over 15. Cotangent, 15 over 8. Cool? Okay, let's look at this one. So if we're trying to find the sine of 45, we're just using our 45, 45, 90 triangle. So sine is opposite over hypotenuse. So x over x squared roots of 2, which is 1 over the square root of 2. If you rationalize that, that's the square root of 2 over 2. Okay, cosine of 45 is the same exact thing as sine, so you end up getting square root of 2 over 2. Tangent of 45, opposite over adjacent, that's x over x, which is just 1. Do the same thing with 30, so sine opposite over hypotenuse, x over 2x, which is 1/2. Cosine of 30, so that's x squared roots of 3 over 2x, which would be square root of 3 over 2. And tangent, opposite over adjacent, x over x squared roots of 3, which is 1 over the square root of 3. Rationalize it, and you end up with square root of 3 over 3. Okay, this last one, sine of 60, so you get x squared, so 3 over 2x, which would be square root of 3 over 2x, or square root of 3 over 2. Cosine of 60, adjacent over hypotenuse, x over 2x equals 1/2. And tangent of 60, opposite over adjacent, x squared to 3 over x, which equals the square root of 3. Okay, these are important. Honestly, I wouldn't say memorize these. I would memorize the triangles, but once you work with them enough, they'll start to be memorized. This is going to really, really help us once we get to the unit circle. Okay, and that's coming up, so do your best. Okay, I think that's all. Yes, thank you for watching. Yeah, enjoy your night, day / whatevs. Take the quiz. Bye.